All right, so section 2 starts off with a review of section 1. So those of you that were gone yesterday, here's a quick overview of what we did yesterday. We said that your end behavior, so right here, these are the 4 possible end behaviors. High, high, low, 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 high, high, low. Those depend on the degree of the polynomial, which is the highest exponent, and the leading coefficient of the polynomial, which is the coefficient on that highest degree term. So we said high, high was for even positives. Even degree, positive leading coefficient. Low, low was even negative. Low, high was odd positive. And high, low was odd negative. And if you want to see that organized a different way, we've got that over here. Positive and even gives us high, high, which again looks kind of like a parabola. Even and negative gave us low, low, like an upside down parabola. Odd and positive gave us low, high, like a straight line. Odd and negative gave us high, low, like a negative straight line. Does that idea make sense to everybody? Those are the only 4 options. Every graph is going to be one of those 4. And the way we tell is for polynomial functions, the degree and the leading coefficient. So now we're going to try that using the shortcut we talked about just a moment ago, the shortcut from yesterday. So here is a polynomial function that's factored. What's its degree and leading coefficient? So I'm looking through here, I see a 2, that's a factor out in front, an x, 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 2, x to the third, 2 times x times x times x. So that 3 is my degree, that's odd. The 2 is my leading coefficient, that's positive. And then if we do a step farther, odd positive is low high. The next one, we have a little negative out in front here, right there. Negative. Okay, now we need to be careful. Right here, there's 2 of those factors, right? So each one has an x in it. So 1, 2 x's from that one. The next one is to the third power. So there's 3 of those. 1, 2, 3. Again, taking the highest degree from each one. And then the last one, there's just 1. So right here, 1 more x. If I multiply that all together, I get 1, 2, 3, 4, 5, 6, negative x to the 6th. Does that make sense to everybody? That's the shortcut that we talked about yesterday. Instead of multiplying it all the way out, just take the highest degrees from each term. But watch out for those exponents. So this is going to give us 6 is even, negative 1 is negative, and that's going to be low, low. Does that make sense to everybody? Letter C, we're doing negative 2x squared. That is one whole term, and it's a factor. Does that make sense? It's the highest degree. It's the whole thing for that factor, just negative 2x squared. The next one, I'm going to take 1x from that one. Then I have this one twice. So 2 x's from there. Or is everybody clear that I can write it like that? Or I can write it as x squared, right? Either of those would be the same thing, whichever you prefer. And then the last one's a little interesting. 1 minus x. The minus x is your highest degree term from that, but it needs that negative. That negative one is its leading coefficient for that x. So we have to put it all together. This one ends up being a negative times a negative is a positive. So plus 2 x squared, 3, 4, 5, 6. Positive 2x to the 6th. That 6 is even again. The negative 1, or sorry, the 2, sorry, the negative 1 was from the last one. The 2 is positive, and that means it's high, high. And our last one, right here, we've got a 3. We have an x plus 1, or just an x, is what I need from there, the highest term. We have, oh, interesting, 2 negative x's, negative x times negative x, or negative x squared. And then we have, for this one, 4x squared. Right, the 4x squared, that's the highest degree term in that last piece, last factor. Put it all together. 3 times negative 1 times negative 1 times 4 would be positive 12. And then 1, 2, 3, 4, 5 x's, 12x to the 5th. 12x to the 5th. This becomes 5 is odd, 12 is positive, so that's going to be low, high. Now, a quick note, I keep writing out odd, positive, even, positive. The hope is today you're going to get to the point where you don't have to write that out anymore. You're going to look at that and say, oh yeah, odd, positive, low, high. Does that make sense to everybody? But if you need to write that out every time, that is totally fine. Okay, some of you, you're like, why are we going over this? We did this for an hour yesterday. We have to have it down for what's coming up next. So now, those of you that were a little bit bored, here's the new piece. So everybody's full attention here, because I'm going to try to go fast. We're now going to take this and add on, not just the end behavior, but x and y intercepts. So if I want to find the y-intercept of something, the y-intercept of a function comes from putting 0 in for x. So for this one, f of 0 is going to be 2 times 0 squared times 0 minus 3 times 0 plus 1 times 0 plus 5. Now you guys are going to get smart on some of these. I could grab a calculator and do, okay, 2 times 0 squared times negative 3 times 1 times 5. Anybody see why I don't need a calculator to do this? What is it? A little louder? What makes this one really easy? The 0, right? If I multiply by 0, everything becomes 0. Does that make sense? 2 times 0 is 0, times negative 3 is 0, times 1 is 0, times 5 is 0. This whole thing ends up being 0. So that is 1 point on my graph. That's the y-intercept. If I want the x-intercepts now, I'm going to set the whole thing equal to 0. This is what we were doing last unit. Set the whole thing equal to 0. So 0 equals 2x squared times x minus 3 times x plus 1 times x plus 5. And remember, whenever I have factors equal to 0, I can set each of those factors equal to 0 and solve for each one. What would make each piece 0? So I'm going to have 0 equals 2x squared. 0 equals x minus 3. 0 equals x plus 1. And 0 equals x plus 5. Each factor equal to 0. And then solve each of them. So this one, divide by 2. 0 divided by 2 is 0. Square root, get 0. X equals 0. There's one of my factors. This one, add 3. X equals 3. This one, subtract 1. X equals negative 1. And subtract 5. X equals 5. Negative 5. X equals negative 5. Okay? So I took each factor and set it equal to 0. And then I solved each of those factors. I see some concerned expressions. From the very end, this guy right here. Does that make sense? X plus 5. Now, one of these factors, yeah, I just ran out of room. Yeah, so I had to wrap around to the bottom. One of these factors is a little bit different than the other ones. The 0 here came from this squared. Because it was squared, there's technically 2 of those. There's 2 x's that each could be 0. Does that idea make sense to everybody? That if I really factored it all out, it was 2 times x. Each of those x's could be 0. So this one, we're going to call this multiplicity. I'm going to abbreviate it mult of 2. And I've run out of room here. I'm going to write it up here to make this a little bit more obvious. 0 multiplicity of 2. There were 2 of those. And then there was a single 3, a single negative 1, and a single negative 5. Those are my x-intercepts for this function. 0, 3, 1, and 5. But that 0 happened twice. That's going to be important in just a minute. Let's try another one. Let's try h. Or letter f, which is h of x. So for this guy, I'm going to find the y-intercept by putting in 0 or x. H of 0 equals negative 2 times 0 minus 3 times 0 plus 1 squared times 1 minus 0. So negative 2 times negative 3 times 1 squared times positive 1. Most of the time, it'll work out this way where they're small numbers. Like it's easy to multiply it all the way out. If you need to use a calculator, that's fine. But negative 2 times negative 3 is going to be positive 6 times 1 times 1 times 1 is just all going to be 6. So my y-intercept is 0, 6. My y-intercept is 0, 6. And I switched colors, unfortunately. I had been using blue for the x-intercept. So we'll use red for x-intercepts this time. So the x-intercepts then means taking the whole thing and equaling it to 0. 0 equals negative 2, x minus 3, x plus 1 squared, 1 minus x. Okay, technically I have a 0 equals negative 2. Is that ever going to be true? Negative 2 can't be 0. Does that make sense on its own? So we're going to leave that one. Yes, it's a factor, but it can't be 0. So it's not going to be an x-intercept. There's no x to solve for with negative 2. But the other ones, 0 equals x minus 3. 0 equals x plus 1. 0 equals 1 minus x. I can solve each of those. Add 3. 3 equals x. Subtract 1. Come on. If I can get that in there. Negative 1 equals x. And then this one's kind of interesting. I could either subtract 1 or I could add x to both sides. If I subtracted 1, I'll get negative 1 equals negative x. Either way, I can multiply that by negative 1 then, but I should end up with x equals positive 1 when I'm done with that one. Any questions about finding those x-intercepts? It's like finding the zeros that we did last unit. Okay, that's not supposed to be new. That's supposed to be something that we've done in the past. It's just there's more of them now. Which of those was duplicated? Right, the second one right here. That one was x plus 1 squared. So this one is technically multiplicity of 2. So everybody, what that means here is this function has 3 distinct x-intercepts, meaning when I draw it, there's going to be 3 places it touches the x-axis. At 3, at negative 1, and at 1. Those are distinct. But remember how there's a bunch of ways to talk about the same thing last unit? Zeros, x-intercepts, roots, solutions. Those all meant the same thing. We're going to add one little differentiation here. X-intercepts, when we say distinct x-intercepts, it's just how many are there that are unique. If they ask for zeros or roots, you're going to include duplicates, okay? So this one, while it only has 3 distinct x-intercepts, it has 4 zeros or roots because of that duplicate. Does that make sense to everybody? I can't graph the duplicate. I can't put 2 points there, but it still counts as 2 when we talk about zeros or roots. Zeros or roots would also include imaginary ones. We'll get to that eventually, okay? But you can't graph an imaginary number, and so, or at least what we're doing. And so, if they were there, they wouldn't count as x-intercepts. Now, do we have questions? We're good? All right, everybody, I want you to look at the homework now. Everybody turn to the homework, and I'm going to do number 2 with you real fast. See, I think I've got it here that I can just open up. I thought I had a copy of the homework right there. See if I got one over here. There we go. All right, so I'm going to do number 2 with you real fast, and then I want you to try number 1. So number 2, degree and leading coefficient. I'm going to solve that. I'm going to get those pieces by using our shortcut. X squared times x times x. X squared times x is going to be x to the 4th. So that means my degree is 4, which is even. And my leading coefficient is just 1, which is positive. Even positive means an end behavior of high, high. Does that make sense? Come on in. X-intercepts with multiplicity. So I'm going to find each of my x-intercepts. X squared equals 0. That's going to give me an x-intercept of just x equals 0, but there's 2 of them, right? That x squared. So x equals 0, multiplicity, cross my L there, multiplicity of 2. Then I'm going to take the next factor. 0 equals x plus 2. If I subtract 2 from both sides, it would be negative 2. If it's only a multiplicity of 1, you don't have to say it. That's the assumed one. You only have to say it if there's more than 1. So that one's just a single negative 2. And then the last one, the x minus 7. 0 equals x minus 7. I can add 7 to both sides. and get my last x-intercept of 7. So my x-intercepts are 0, multiplicity 2, -2, and 7. The y-intercept, I'm going to put 0 in for x. So f of 0 equals 0 squared times 0 plus 2 times 0 minus 7. That ends up being 0 times 2 times -7, which is all just 0. That's my y-intercept. So how many distinct x-intercepts do we have? If I look here, I listed 3 x-intercepts, 0, -2, and 7. That's 3 distinct. Distinct means unique. Okay, not duplicated. So 0, -2, and 7 are my distinct x-intercepts. When they ask for zeros or roots, count the duplicates. So while there were 3 distinct x-intercepts, there are 4 zeros. All right, I want you all to try number 1 right now. Everybody try number 1. Okay, so we're going over the answers for number 1. We said degree was 3 and odd, leading coefficient was 1 and positive. Mark, what's the end behavior then if it's odd and positive? Careful. Because that would be odd and negative. Low, high, there we go. Low, high. X-intercept with multiplicity. Nathan S., give me an x-intercept for this one. You don't have to do all 3, but what's one of them? Where do you want to hit? So don't multiply it back out. Don't take that original one, or don't take the 1x cubed that we were doing for the degree and leading coefficient. Just take the original factors. So like 0 equals x minus 2. What would that be when you solve it? There you go. So that's our x-intercept. X equals 2. And there was only one of them. It wasn't squared. It wasn't cubed. There's only one. If there's only one, you don't have to say multiplicity 1. Okay. So there's one x-intercept. Davian, can you tell me another x-intercept then? And what would that actually be for when you solve it? Yep. So we've got 2. We've got -5. And then the last one, Johnson, what's the last x-intercept? +1. So there's our 3 x-intercepts, none of them with multiplicity. The y-intercept then. Nick, were you able to find the y-intercept for this one? Okay, so does it make sense that you just put 0 in for x? Does that idea make sense? That's how you do it. So if we do that, 0 minus 2, 0 plus 5, 0 minus 1, just plugging in 0 for each of those. We should end up with -2 times 5 times -1. So what would that be, Nick, when you multiply that all the way out? So the 2 negatives are going to cancel out. +10. That would be our y-intercept. If you want to put the point, you could say it's 0, 10, if that makes more sense to you. But make sure you got that y-intercept of 10. So then how many distinct x-intercepts did we end up with? Ethan Bravo. We had 3. And then how many roots were there? It's not here today. Ednan, were there any duplicates in the x-intercepts? So if there's no duplicates, the number of x-intercepts is the roots. So how many roots did we have here, Ednan? It's 3 again. Now, Dom pointed out something that I hadn't mentioned to everybody yet. Remember how we found the degree earlier? That degree is always going to be equal to the number of roots or zeros. okay? The degree will always be the number of roots or zeros. So whatever you put up there for degree, you could put that down here. Oops, not for the x-intercepts though. Down there. Why can't it be always the x-intercepts? Look at number 2. Why wasn't it 4 for number 2? Because 4 was our degree and 4 was our zeros, but there are only 3 x-intercepts. Go for it. We have the same one twice, and distinct x-intercepts means don't count those duplicates. Does that make sense? So you can have fewer x-intercepts than your degree, but your degree, your zeros, your roots, those will always be equal. They'll always be the same. All right, back to the notes, and let's put it all together. How do we take all this information and graph it? Now, we're actually going to skip A and B back here. I already told you everything that I would have shown you with A and B, so we're going to skip those. But we are going to make a note over here. Multiplicity is important. We talked about multiplicity on the previous page. If the multiplicity of an x-intercept is odd, go ahead and fill that in your notes. If it's odd, it goes through the x-axis. Whereas if it's even, we're going to call it a bounce or a touch. It's not going to go through. Again, it's like a ball bouncing off a table. It comes down, it hits the table, and then changes direction and keeps going. It doesn't crash through the table. Does that make sense? We're going to bounce off. And you're going to see that on some of our graphs here. The first one, it doesn't actually come up. Here's what we're going to do. We're going to find all that information that we just looked at in questions 1 and 2. We're going to find it all without listing it all, like without that big description. And we're just going to label our graph, put the important things on it, and then connect all the dots. So I need end behavior. Everybody, again, if you're tired, I guess it's Tuesday, it's been a long week already. I need everybody's full attention right now, okay? Because this is where we're going to put it all together. So wake yourself up, make sure you're paying attention for this piece. So here we go. I need the end behavior, which means use my shortcut, x times x times x. This is going to be x cubed, odd, positive. So this is in the notes. Everybody's good. This is in the notes. Number 1, odd, positive, which is going to give me a low, high end behavior. So right now on your graph, on the left side, put an arrow down, and on the right side, put an arrow up. Your graph needs to do that. It needs to follow those 2 directions. Now, let's find the x-intercepts. Take all the factors and equal them to 0. So 0 equals x plus 3. 0 equals x minus 2. 0 equals x minus 4. A lot of you are going to get to the point where you don't even have to write that out. You're just going to look at it and say what those zeros are. But here we can help see, okay, I'm subtracting that 3. So my first x-intercept is -3. -3 equals x. I can put that on the graph. There's my x-intercept of -3. And add 2. 2 equals x. There's another x-intercept. I can add 4. 4 equals x. There's another one. There's my 3 x-intercepts. Now I need the y-intercept. I'm going to do the work down here at the bottom. 0 plus 3 times 0 minus 2 times 0 minus 4. Essentially 3 times -2 times -4. 3 times -2 times -4 is going to be 24, right? Yeah. Notice how the y-axis isn't labeled. That was on purpose because there's no way for us to put 24 marks on there. So you just make a mark in the positive section and say that right there is 24. Just label it. Put a point. If you want to label the x-axis as well and say, okay, -3, 2, and 4, you can do that, but you don't really need to because it's got the hash marks. Now connect the dots following your end behavior. So I'm going to start low, come up, down, and back up. And there is my graph of y equals x plus 3 times x minus 2 times x minus 4. Yes, it's a simplification. It's a sketch, but it's got all the important parts. Does that make sense to everybody? Make it smooth, okay? No straight lines. This isn't absolute values. Make it a smooth curve as much as you can, going from left to right. Does anyone have any questions about what you just saw? All right, so let's do one more, maybe two more. Number 2 has a little bit of an issue. It's not fully factored. I can find the end behavior as is. -2 times x squared times x, right? The biggest degree from each term, or the highest term, highest degree term from each factor. There we go. -2 x to the third power. So -2 x to the third power, that's going to be odd and negative. That's going to give me high, low. So I can put that in right now. It's going to start up high and down low. But now this middle one, the x squared minus 2x plus 1. If I want the factors and I want the x-intercepts, I need to finish factoring that. What multiplies to 1 and adds to -2? -1 and -1. Does that make sense to everybody? So this is going to factor into that -2 is still there, x minus 1 times x minus 1, or x minus 1 squared times x minus 3. Now I have a little note for you over on the side. If you want to be a little bit faster with finding your, where is it? I thought I put it on here somewhere. I thought I had a little reminder about how you, there it is, right here. That's on the previous page. If x minus b is a factor, then b is your x-intercept, the opposite. That's a shortcut. Some of you are already starting to use that. So if I'm looking at this one, and I see that x minus 1, I know that my x-intercept there, my x-intercept is positive 1. And here, my x-intercept would be positive 3. So 1 and 3. My y-intercept, I can put 0 in for x, either to the original one or the factored one. -2 times 0 minus 1 squared times -3, 0 minus 3, which would be -2 times -1 squared, or -1 times -1 times -3. -2 times -1 times -1 times -3 all becomes just 6. Is everybody following so far? Okay. So all of that together, that's my y-intercept. That's up here at 6. Now, we're about to have a problem. Don't sketch your graph yet. I'm going to do it, and I'm going to show you what the problem is. I'm going to talk about what I missed here, why it's not going to work. So I start high, I come down, I go through my first one, I go through my second one. How am I going to get down? How am I going to get to a low end behavior here? I can't make a new x-intercept. I can't just go through the graph again. So we made a mistake. Specifically, remember how we had said that if the multiplicity is odd, we go through, but if it's even, we bounce off. So right here, which of those x-intercepts had a multiplicity of 2? The x minus 1, right? Right here, that was squared. There's 2 of those. So this one should be a bounce. Label it, put a B, remind yourself that you're going to bounce off there. So now when I draw it in, I come down Starting high, I hit my y-intercept, I bounce off and then go through, and now everything lines up. Does that make sense? Now, the hope is you're going to get faster and faster as you do these. So number 3, I'm going to do real fast. Negative x squared times x is going to be negative x to the 4th. That's going to be low, low. I have an x-intercept right here of 0, multiplicity 2. And an x-intercept here of negative 4, multiplicity of 2. So both of those at 0 and negative 1, 2, 3, 4, those are both going to be bounces. My y-intercept, I put in 0, 0, negative 0 squared times 0 plus 4 squared is all just going to be 0. And that's, if you haven't figured it out already, if you have an x-intercept at 0, your y-intercept is also 0. If you have a y-intercept of 0, you're going to have an x-intercept of 0, because 0, 0 is both an x-intercept and a y-intercept. So now, low, low, got to start low and low, come up, bounce off, come up, bounce off, and down. There's my graph. I do not expect you to be that fast at the beginning. You don't ever have to get that fast, but you have to be able to find those pieces, and hopefully you start to get a little faster as we go. All right, we've got about 10 minutes left. So everybody look at number 3 on the homework. Now, I've pared down the homework for today. We're actually just going to do 1 through 13 odd. And then on block day, we're going to add in just a little bit more. On block day, we're going to look at we're going to go ahead and look at numbers 15 through 18. Okay. But for now, 1 through 13 odd. So everybody take a look at number 3. I'm going to call on some of you. Let's start with the degree and the leading coefficient. So if I use my shortcut, what do I end up with as far as degree? Go ahead. Do you have a question or you want to answer? Go for it, Jaime. Odd positive, right? Because it's an x cubed. Odd, positive, low, high. So it starts low, ends high. Next, some x-intercepts. Ashram, can you tell me an x-intercept? Positive 1, right? This one's going to be the opposite. Positive 1. Ethan Rocca, can you tell me another x-intercept? So on number 3, we said 1 was an x-intercept. What other x-intercepts do we have? Perfect. Negative 3, and somebody else, let's get the last one. Alyssa, can you tell me one more x-intercept? Positive 4. There we go. And now I need my y-intercept. Joey, can you find us the y-intercept? Either tell us how to do it or just tell us what the answer is if you already know what it is. It is 12. We're putting 0 in here, so we end up with essentially negative 1 times 3 times negative 4, which is exactly what Joey said, 12. Is that everything I need? Let's double check. Are there any bounces? Were any of those x-intercepts duplicated? Nope. So that should be it. Start low, up through the first one, hit that 12, down and back up. There is our graph. So we've done 1 and 3. You have 5, 7, 9, 11, 13. So 5 problems. You've got 5 minutes, which means you're probably not going to finish, but you could probably get 1 or 2 done. Yes, LJ. So the bounce is if you have the same x-intercept more than once, or specifically an even number of times. So real quick, if I had an x plus 2 cubed, would I bounce off of that one? No, it's still odd. Does that make sense? I don't think it comes up in the homework. It's either 1 or 2. But if you had a 3, it would go through. All right, so again, the homework 1 through 13 odd. We're going to do 15 through 18 tomorrow or Thursday. So eventually it'll be 1 through 13 odd and 15 through 18. You can do the other ones for extra credit.